The meeting's over. Now it's time to do code reviews. Code reviews can be pretty intimidating and confusing. So it's really important to understand the purpose of a code review is to focus on what humans can do, not what computers can do. And that's why it's very important for any modern software setup is to utilize common tools. For example, you don't want this code review to focus on formattings, tabs versus spaces. Does the brace go on this line or next line? Why? Because I have a tool available for every conceivable programming language that will automatically format my code for me. So we don't need to focus on that. The second issue is we want to avoid spending time on things a computer can handle. There's something known as static code analysis, which is a series of tools in every conceivable programming language for finding common coding issues and not allowing you to have them inside your code base. And so the idea is in a code review, you don't have to discuss these common issues like an exception that has no logging statement, for example, in the Java space. You can focus on the human stuff. And then finally, because we're following CI and CD practices, we don't discuss broken code. If you made a code change and it broke something via your CI practices, you have 15 minutes to either fix it or revert it. Broken code's irrelevant. Don't bother talking about it. Just either revert it and try again or fix it. And the next most important part of a code review is no ego. This isn't about senior or junior. It's about having a meeting of the minds to get multiple perspectives on how something was implemented. This is important because we're trying to find ways to build this in a way that's both efficient, but also writing code in a way that can be maintained. You know, the first priority is the code works. The second priority is that someone else can understand it. Because at some point, 4 years from now, somebody else with no context is going to have to come in and understand and fix this. So we want to make sure it's readable, it makes sense, it's doing the right things. In our case, from a Dev2 perspective, it's just Dev2, the lead dev, and potentially the QE sitting here talking about what I did. And so I'm going to start with, from a diagram perspective, the effort I did to reverse engineer out the implications of my change. So I go through, I'm changing this REST util service, and red here is U. It's used in these three services. Those three services are referenced by these controllers, and those controllers are used by the front end for the overall features of getting price, image, and in stock for our products. And so I'm asked questions. How did you figure this out? I figured this out by just using the find references tool of all instances of where the class in question for RESTful communication is used in the application. And I also did a general search in Git to make sure that this covers everywhere using REST template. Okay, good. Well, what's your code look like? Well, we'll start with looking at your code. I'm using the HTTP builder for OK HTTP. I'm using this, and I'm going to cite some reasons by its popularity on Maven, in this case for a Java technology, good documentation, industry standard, and throw out for the QE, hey, if you're using Postman, you can actually generate OK HTTP Java code in the option on the right. So that sells the QE on this work. And then we talk about, well, how did I test this? Well, while there are unit testing implications just from a coding standpoint, the real important part for the application standalone is the integration testing. And so I go in and I show the test cases for how get price and get image and get in stock didn't actually have to change, but their underlying calls to the URL utility did have to change.